Here we are given this function f of x equal to under root sin x plus sin inverse 2 absolute value of x by 1 plus x square. Right. Now, what is the domain of this function? We have to take care of two things here. One is the sin x is within the square root. So obviously sin x should be greater than or equal to 0. At the same time, that x, whatever is the x, if it has to be in the domain, that means 2x by 1 plus x square should always lie between minus 1 and 1. Right. X should always lie between minus 1 and 1. And sin x should always be greater than or equal to 0. These are the two conditions. Let's see. Let's see for these two conditions what will be satisfied. Sin x, it has to be greater than or equal to 0. What does that mean? X should be either 0 to pi or 2 pi to 3 pi or 4 pi to 5 pi, whatever. Okay, basically that is something like 2n pi to 2n plus 1 pi. Right. 2n pi, 2n pi, that means 4 pi to 2n plus 1, 4 plus 1 pi, or 2 pi when n equal to 1, 2 pi to 2n plus 1, 3 pi. Okay, likewise. So basically, all even multiples of 2 pi to the next pi, all even multiples of pi, 2 pi to plus one more pi. So 2n pi plus another pi. That is 2n plus 1 pi. Okay, all even multiples of pi plus one more pi. So in all these cases, sin x is positive. So this is fine. So this is the domain of this x. Now, whether this x satisfies this or not, that means 2 into absolute value of x should all by 1 plus x square should always be between minus 1 and plus 1. Firstly, there is this absolute value of x. That means this numerator 2x is always positive or greater than or equal to 0. X square is also always greater than or equal to 0. That means 2 into absolute value of x by 1 plus x square will always be greater than or equal to 0. Okay, it will not even be negative. It will always be positive. 2 into absolute value of x by 1 plus x square is always positive, firstly. And at the same time, if we take this one, 2 into absolute value of x plus 1 by x square, this is an even function, right? F of x equal to this. F of minus x is also equal to this only, right? If you, because even if x is 2, then it will be 2 into 2. X is equal to minus 2. Then also it will be 2 into 2 only because there is absolute value, right? F of x equal to f of minus x. Basically, the graph of this function will be symmetric with respect to y-axis. It looks something like this. Okay. Now, whether this is within the range of minus 1 and 1 or in the range of, if we just realize it is not even about minus 1, it is about 0. Whether it is in the range of 0 and 1 or not is a question. Okay. Now, if we take 1 minus x whole square, this is always greater than or equal to 0. You can take x minus 1 also. What does that mean? 1 plus x square minus 2x is always greater than or equal to 0. That means 1 plus x square is always greater than or equal to 2x. That means 2x by 1 plus x square is always less than or equal to 1. 2x by 1 plus x square is always less than or equal to 1. Even when, so in this case, if we make it x as positive or negative, it doesn't matter. So if x is negative, then this would have been negative, but here there is absolute value of x. So 2 into absolute value of x by 1 plus x square is also always less than or equal to when x is when x is greater than 0. Right. So then absolute value of x is also x, right? X is greater than 0, then 2x by 1 plus x square is always less than or equal to 1, right? So now, and when is this 1? When x equal to 1. When x equal to 1, 2x is, the numerator is 2 and denominator is also 1 plus 1 is 2. So this function, it looks something like this, right? it looks something like this. It goes up to 1, and then and then it will taper down towards infinity. It will tend to 0. For example, 2x by 1 plus x square. What we can write it as 2x by x plus 1 plus x square by x, which is nothing but 2 by 1 by x plus x. Right. As as x tends to infinity, this tends to 0, and this tends to infinity. So the denominator becomes very big. So obviously this will tend to 0. Okay. So but we are not so much concerned about how this graph runs and all. We are just concerned about whether this graph is always, whether this expression is always lesser than or equal to 1 or not. It is clearly it is greater than 0, greater than or equal to 0. That is clear because this is uh, because this cannot be negative. This cannot be negative. So that we are clear. Now we are clear that this is always lesser than or equal to 1 also. Now, if we are to draw the graph of 2x by 1 plus x square, it will look like this. Okay. Now, because it is 2 absolute value of x, this whatever is in the bottom part will shift upwards. So this graph 2 into absolute value of x by 1 plus x square, this is even. Okay. But 2x by 1 plus x square, this is odd. Right. If you replace x with minus x, then we will get minus of 2x by 1 plus x square, right? So that is odd. So please note the difference in the graphs. This one is the odd one. This one is odd one, which is 2x by 1 plus x square. When x is negative, this will go down. But when we are putting absolute value of x, this whatever is this portion which is below the x-axis will flip upwards. So, and this function becomes even function. That means that is this graph. Here we are given the even function, not the odd function, right? Even if you are given the odd function also, it doesn't matter much because 2x by 1 plus x square will still lie between minus 1 and 1. In this case, it will lie between 0 and 1. In this case, because we are putting absolute value of x, it will lie between 0 and 1. Okay. So sine inverse of this thing is lying between 0 and 1. Okay. So basically what we are trying to say here, x can take any value. X can take all negative values also, all positive values also. It doesn't matter because whichever value of x you will take, this part will always lie between 0 and 1, between 0 and 1, right? It will always lie between 0 and 1. So sine inverse is possible. So there is no restriction on x in this part. There is some restriction on x in the root sin x part. What is that restriction? It cannot be between pi and 2 pi or 3 pi and 4 pi likewise. So net net in the second part there is no restriction. First part there is a restriction. That restriction is 2n pi to 2n plus 1 pi. So finally the domain is 2n pi to 2n plus 1 pi. 2n pi to 2n plus 1 pi. Okay, so please note here there are open brackets, here there are closed brackets. What do we want? We want closed brackets because this is in numerator only. If this was in denominator, probably would not have taken, we cannot take closed brackets. But this is in numerator only. So we can include 0 also, we can include pi also. Right. In both cases, this value's root sin x will become 0, which we are okay with. Right, guys? So this is the correct answer. Thank you.